Welcome to ERC Tipsnology. In this video, we will be learning how to create a series parallel circuit with 5 resistors, 1 voltage source, and another current source connected together. And we will be finding out what would be the voltages on each of the resistors and what are the currents through each of the resistors using Multisim. So let's start. The first step that you will do is to click on place component, and then let's click on the basic. After that, click on resistor and type here 300 ohms. Click OK and drop the resistor. And then we can close this and let's zoom in so that we will see it better. And let's place again another with a value of 400 ohms on the screen. And another one, we can just click OK, and we will be placing here 5 resistors. So we have R1 up to R5. After that, we will click on basic sources, power sources, and let's put on the DC power supply on the left side. And then let's click on the power sources again, and let's put the ground over here, and let's see where is the current source. So we will be seeing the current source somewhere here in the signal current sources, and let's click on the DC current. OK, and drop it on the right side. And let's close this and let's start fixing the circuit so that it will be arranged properly. And we will be placing all the R1, R3, and R5 at the top and R2, R4 in the middle side or in the middle part. After that, let's connect R1 to the V1. We'll just change the name later, R1 to R3 and R3 to R5. And then R5 will be connected to our current source on the right side. So let's connect this one. And let's also connect the current source and the voltage source together. Now let's rotate this R2 and R4 90 degrees clockwise and connect them between R1 and R3 for R2 and the R4 between R3 and R5. And let's try to fix this side at the lower part over here. Let's put it downward. Let's see. Okay, and let's delete this part. And okay, let's just repeat it again. Let's position the component correctly and connect the voltage source to the current source. And let's put this down over here. Let me just fix this one. Okay. So you can drag and drop. So let's move the ground. That's it. And then put down the R2 on the ground side and the R4 also on the ground side. And then let's connect the ground. That's it. Now let's fix the right side and put this up. And after that, we have to change the values of our resistor. Let's make this 500 ohms. R5, let's make it 300 ohms. R4, let's make it 200 ohms. And then the voltage source, let's make it 10 volts. And the current source, let's try first 800 milliamperes, or let's repeat that one. Just put 800 M and it will be 800 milliamperes. Now that we have the circuit, let's put a multimeter on this part. Let's try to measure the voltages on each nodes. So let's put another one, but let me fix this first. Put the XMM one down. That's for this multimeter, and make sure it's a voltmeter. And then let's click on the second one and position it over here between R1 and R3 and double click it to display the value of the multimeter XMM2. And then let's put another multimeter over here between R3 and R5 and double click it to show the value of the XMM3 and XMM4 on the last side on the right. Now, after that, let's connect the positive of the multimeter number 1 here and multimeter number 2 between R1 and R3, and between R3 and R5, let's connect the multimeter number 3, and multimeter number 4 will be between the R5 and the current source. Now let me just arrange the multimeters properly so that it will look nicer. And let's put the negative side of the first multimeter on the negative side of the battery or the voltage source. And let's change the color of the negative to black or something darker like this one. And the other one also, let's change it to another color instead of red. That's it. And let's connect the multimeter 3 on the ground. And of course, the multimeter number 4 on the ground also for the current source. Although it's a current source, we'll measure also the voltage there. And let's see what happens when we run it. So we have 10 volts, 36 volts, 124.59 volts, and 364.59 volts with these particular conditions. But let me experiment by changing the value of the current source to a lower value. Instead of using 800 milliamperes, we will change it later on. But let me measure also the current here. Let's put another multimeter over here, and this time we will cut the wire between R5 and current source, and let's connect the positive of the multimeter, which will be the ammeter later on. We will make it ammeter and connect it on the current source, and the other side will be connected to R5. Let me connect this one here. And so the multimeter number 5 will serve as the current meter or the ammeter for our measurement. Let's make this black. Okay, the negative side. And then click on OK. And then let's double click XMM5 and make sure it's letter A for ammeter and then DC with that line. Let's run it now. And see, it's giving us 800 milliamperes. And our voltage is 10 volts. And we have here the value of 36 for that one, XMM2. But let's put a text on our circuit. Let's say we put here VS to represent the voltage source. And let's put another one between R1 and R3, and let's call it VA. And let me just fix this one. Okay, let's see if we can change the font color or the size. Yes, we can. And let me just click here bold to make it clearer and click apply. OK. And let's copy if we can copy this one. If not, then we will just simply place or put another text for node VB, and that would be between R3 and R5. So we need to place or to put another text between R3 and R5. Let's call this one VB, and let's see if we can make it bold, and the color will be red. Okay, that's it. So we may also change the color of VA. Let's also make it red. That's it. So now we have VA node and VB node. Now let's run this, and we got the answer here for the multimeters values for voltages and one current. Now let me change now the value of 800 milliampere to 100 milliampere. I think I have a mistake here. I put mega, so our values will be overloaded. Let me correct that one. Let's make it 100 milliampere. Now that it's 100 milliamperes, we can also measure the currents or the voltages of this circuit in this way. Let me see. So let's put another voltmeter here on the, let's fix it again, voltmeter here using the XMM1, and let's put more voltmeters in our circuit. So we have here already placed the multimeter number 1 or our XMM1, and then we have to put the second meter. So we click on the second multimeter and let's put it over here. And let's connect it on VA, and the negative will be connected to the ground. And let's put another voltmeter. Make sure it's V and DC. So let's put the XMM2 down, and then let's put the third voltmeter here to measure the voltage across VB or across the R4. And let's make the negative side connected to the ground. After that, let's create another multimeter. Let's make sure it's down here. Now let's click on another voltmeter and or multimeter, and this time let's use this as a current meter or ammeter. Let's connect the ammeter between the R5 and the IS, but let me flip this horizontally. So I'll connect the positive side of the meter over here, and the negative side will be connected over here in the R5. And then let's double click and put this beside that XMM4 to see, and then click A to make sure it's an ammeter. And then let's run, and you will see here 10 volts and 8.525 volts. For this one is 16.721 volts, and this has 100 milliamperes. Now let's stop running the system, and let's see what else can we do over here. Let's copy this meter, for example, or let's cancel all the other meters, and let me show you. Copy this multimeter or ammeter, and let's put it over here near R1. Let's move R1 to the left. Let's adjust R3 in the middle, and then the multimeter number 1, XMM1, will be used over here on this side. And let me just click this XMM1. That's XMM1. Let's put it here down near the XMM1. That's it. Now let's copy this again or paste, and after pasting we have another one. Let's get the value from here and put it here down. And we have XMM2, and paste another one for multimeter number 3 and put it here. Let's put another multimeter. Let's copy this one and paste the one here between VA and R3, and let's move this XMM5 over here, and let's copy this multimeter 5 and let's paste it here on the right of R3, and let's put the value on the right. Now I'm doing this so that we will see all the possible values of the currents on the left and right of the resistors R1, R3, and R5, and the values of the currents on across or along R2 and R4. So now I'm in the multimeter number 7. I copy that one and paste it here, and right click paste. I have the other one, number 8, and I put it here. Now we can copy and put another one here, but I don't think we need this because we already have XMM4. So let's just put it here on the right side of the current source. That would be number 9. And that's it. We have a lot of current meters now. And let's connect the first one. Let's flip this horizontally so that the positive will be here. Let's try this one. Connect it on the positive. Connect this on the negative on the R1, and then let's cut the wire between R1 and VA, and let's flip the multimeter to the positive on the left and the negative on the right. Now in this way, the current will be coming into the VA, but we can also make it like the currents will be moving out or coming out from VA. So if that's the case, the VA must be positive, and let's change the position of the current meter. Let's make all the currents like moving out of VA. So let's make the VA as the positive side of the current meters. So let me just remove the wires again, and let's correct this one. Let's flip again the meters horizontally so that the positive will be on the right side, And let me connect the positive of the ammeter to the VA, because the current will be moving from VA going out or coming out from VA. So the positive will be from the right, which is R1, going down to the VS. That would be our assumption only when we do this, because we don't really know how the current will be. But when it becomes negative later on, then it means the direction will just be the opposite. Now let's remove this and let's make the positive from VB, and the negative over here going to R3. And here, the positive, let's flip the multimeter 5 horizontally, and the positive must be from VA, and the negative will go to the R3. Okay, and then let's remove this wire between R5 and VB, and the positive must be from VB, so flip the meter horizontally and connect the positive on the VB and the negative on R5. After that, let's see the multimeter 4. Okay, let's remove this, or let me analyze. All right, so it should be flipped. So let's flip this horizontally, and the positive will be on R5, and the negative would be connected to the IS for multimeter number 4. And then the next step is, let's say, the multimeter number 3. Let's put it on the left side, and let's see here positive from VA and negative on the. Let's delete this wire and connect the negative on R2, because remember, we have to cut the wire when we measure the current. And then let me make this as black or dark color to represent negative side of the multimeter. Although you don't really need to do this, but it would be better to make the negative black in our display. So I'm making all of the negative sides of the multimeter as a dark color, so that we can easily see it in the right way. Because in the real world, the DMM, digital multimeter, really has black color on its negative probe. So I'm making all of the negative sides of the multimeter as black. As you can see here, I'm clicking the color black or dark blue, if you may. And let's see the display now. Let's click OK, apply. That's it. Now we have to run, and you will see the values of the currents along each of the wires or the resistors where we cut the line from. So we have here negative 4.918 milliamperes with the other values for the currents of all the so we have here 21.311 milliampere for XMM3, and you may see which one we forgot to connect. I think we forgot some for XMM7. Let's connect it. Okay, and what else? When we click XMM5, you have to look for XMM5, and you will see it's 16.393 milliampere. So you double click the meter, and you will be seeing this appear and appear like this one, XMM3. Double click XMM1, and you will easily see which meter you are using. Now we forgot the meter number 9, so let's stop running the circuit and cut the wire below IS, and let's connect the positive on the ground here and the negative here on the IS. And so when you run it, it will display the XMM9 of 100 milliampere also. You can double click it to display it as given. So that's it. That's how to create a circuit in Multisim using the voltage source and current source and 5 resistors connected in series parallel. And we have shown you how to measure the voltages on each of the branches, including the voltage source and the current source and all the resistors. And we also showed you how to measure all of the currents flowing through the resistors or each of the resistors. So thank you so much for watching this video. I hope that you will support our channel by subscribing. So please subscribe. Have a nice day, everyone. Thank you.